Washington State University. Go Cougs!
Hello everyone. In this video, I'm going to cover the Pandas data frame, part 1, meaning in the subsequent video, we'll finish our discussion of a Pandas data frame. So a data frame is a two-dimensional labeled data structure. It has an index, just like a series, where each value in the index maps to a labeled series. The labels associated with the series are the names of each series stacked in columns. So you can think about each name of our stacked series as a column name. I think it helps to think about a data frame like an Excel spreadsheet, where in Excel, each row is labeled as 1, 2, 3, so on and so forth, such that it is uniquely identified. And each column is labeled as A, B, C, D, etc., so it also is uniquely identified. If you want to identify a cell, you would specify a row label and a column label that would uniquely identify a cell. Now, we can construct data frames from many different types of input, including a dictionary of one-dimensional array-like objects, two-dimensional ND arrays, series, and so on and so forth. Let's take a look at an example where we're going to construct a data frame from lists. So what I have here are 3 lists of 4 items, and each item is a city in the state, such as Seattle is a city in Washington. And these are ordered such that these are the 4 most populated cities in these states. I want to construct a data frame to represent this information. So the first thing I'm going to do is I'm going to stack Washington, Idaho, and Oregon into a list, and I'm going to construct a data frame from this nested list POPs. So if I run this, I get this output from the data frame DF. Since I didn't specify any index labels or column labels, and these weren't series that were named, I get the default numbering or labeling system 0 through 1, 0, 1, 2 for 3, and 0, 1, 2, 3 for 4. So now, let's take a look at how we can replace 0, 1, 2 and 0, 1, 2, 3 with more indicative labels of what's stored in this data frame. So we're still going to create a data frame from POPs, but we're going to specify the index to, instead of being 0, 1, 2, be state abbreviations for each one of these state lists. And then for our columns, we're going to specify 1, 2, 3, 4 to denote a 1-based ranking system. So let's do np.arange 1 and up to lane of Washington plus 1. And then we'll print out df. So now we have the same information stored here, but our labels make this so much easier to work with. If I wanted to find out what's the 3rd most populated city in Oregon, I could index into df sub Oregon, sub 3, and get the value Salem very quickly. Let's take a look at another example where we're going to construct a data frame from dictionaries. So here I have my same city list, Washington, Idaho, and Oregon, and I'm going to put those into a dictionary, which is a natural mapping structure from Washington, the abbreviation, to the list Washington, etc. And if I run this, I get a very similar data frame, except 0, 1, 2, 3 instead of 1, 2, 3, 4. And our columns are in fact our rows from our previous data frame. So let's investigate this further. Let's first update df2 such that its index is increased by 1, that way we have the same index as we had columns in our previous example up here. Now we can see that they are exact transposes of each other. In fact, we can programmatically test this out if we would like. Let's do df2t gets the transpose of df2, and we get the transpose just like we would with NumPy and dArray. And since they're in a different order, previously we had Washington, Idaho, Oregon. Here we have Idaho, Oregon, Washington. Let's go ahead and sort the index for each one, just to make sure that they're in the same order. Print them both out. And let's do an element-wise comparison to see if these are in fact the same. And we see they are the same, and element-wise they are the same as well. So one little example that I'd like to show you is what happens if the dictionaries we use to create a data frame don't have the same keys, meaning we're going to have an index for each one of our series or each one of our dictionaries that aren't aligned. So I have some code here which includes the populations for each one of our top 4 most populated cities in our states, Washington, Idaho, and Oregon. And I construct a dictionary mapping our state abbreviation to each one of these dictionaries. Now, Seattle, Spokane, Bellevue, and Leavenworth are not keys in Idaho. So we already see that these indices are not going to line up for each one of our columns. So if I run this, we see that we do retain all indices, but NaNs, are not a number, are used to fill missing values. So if you ever see these NaNs, it could be for several reasons, but one reason to investigate would be perhaps your indices are not aligning when you're constructing your data frame. So let's work one more example of constructing a data frame, this time from an ND-array. So let's construct a random 2-dimensional ND-array. Import rand_n, and let's have rand data be a 3x4 matrix, and we'll construct a data frame from this random data, and let's set the index to be alphabetical, so A, B, C. There's 3 because it's a 3x4, and let's set our column names just to be somewhat arbitrary. Let's do col 1, col 2, col 3, and col 4. And let's print out rand df. And here's our data frame, constructed from a 2-dimensional ND-array object. So let's close up this lesson by looking at how we can work with columns in a data frame. And when we first introduced the data frame, we said that we can think of a data frame like a dictionary of like index series objects, meaning we've got these series and they have similar indices and they're all stacked together. And the name of each one of those series is the name of that column. So let's take a look at working with columns. So I'm going to grab this previous example here and we'll work with that. So let's select column 2 and print it out. So if I print out column 2, here's column 2, essentially these values here. let's go ahead and modify one of the columns using assignment. Let's broadcast 100 to all of column 4. So we'll replace all of those values. There we see column 4 is replaced with all 100s. Next, let's go ahead and add another column. Let's call this column 5. And notice this is looking just like how we would add a new key value pair to a dictionary. So let's set column 5 to be a Boolean column, whether element-wise column 1 is greater than column 2. And here's our Boolean column here. Next, let's go ahead and add a new column that's going to be the sum over all of the columns. So randf.sum, and our axis will be columns. So here is our sum, summed over all of the columns in this row. Let's take a look at another way we can add a column into our data frame with the insert method. So we'll insert at position 2 a new column called ones, and we'll go ahead and broadcast 1 to every single location in this column. And here's our ones column placed at position 2. So here's position 0, 1, and here's position 2. Let's see how we can delete columns. So let's go ahead and delete column 5. So here we had column 5, and now it is gone. So we use the Python reserve keyword del, just like we would use if we were deleting a key value pair from a dictionary. Let's take a look at another way we can remove a column, and this way we'll retain the column as a series. So let's have sumSer be randf.pop. Let's pop the sum column, and we'll go ahead and print randf to see that the sum column is gone. And we can print out sumSer as well as the type of sumSer, just to confirm that it is in fact a series. So sum is gone from here, and here's sumSer, and it is in fact a series.